All right, so this one was like, well, tonight you'll do some factoring too. This is like the first few examples we did yesterday. Is there a GCF to start? No, got to be something that goes into all four of these, right? You know, two goes into these three, but not this one, and four, or that's about it, I guess. Really. All right. So it's got four terms. So how do we do a four-term factoring problem? What we call it? We call it grouping, right? So we're going to group first two, last two, like we normally do. And since this third term had a minus there, I put it inside the group. And then I take out GCF. So what's the GCF of the first group? X squared. And 2x cubed divided by x squared is 2x. And 7x squared divided by x squared is 7. And remember, if that's minus, like this situation, we always pull the minus out. And what goes into 8x and 28? 4, right? So we get 2x plus 7 again. Negative 8x divided by negative 4, positive 2x. Negative 28 divided by negative 4, positive 7. So these are the same. So that's one of my factors. And then my GCFs I pulled out is my other. Is it factored completely? No. This is a what? Difference of squares, right? You guys are so smart. Oops. All right, so I got my 2x plus 7 still. With this, I can make my difference of squares. I make two sets. And the square root of x squared is x for the front. Square root of 4 is 2 for the back. One's addition, one's subtraction. So I'm going to get 3 zeros. And that's what I expected, right? Because it was to the third power. All right? So my degree was 3, so I'm looking for 3 zeros. And I can just set each one of these factors equal to 0 to find those 3 zeros. So I would add 2 for this one. So one of my zeros is positive 2. Subtract 2 for this one. So another 0 is negative 2. And here I'd have to subtract 7. And divide by 2, which would be negative 7/2, or if you want the decimal, negative 3.5. So either way, write it as a fraction or decimal. But there's our 3 zeros for that problem. Solving by factor. Okay? So some of your problems today, you can solve by factoring. If you can't factor it, then we'll go to the calculator and look for our zeros, okay? And we'll have a few examples here in a few minutes. So answers for last night, numbers 1 to 6. 3 is one of our zeros, and it works twice or has a multiplicity of 2. So if it works more than once, put next to it, like I would just put like a 2x next to it in parentheses, telling me that it works twice. Negative 5 works once. Like all these just worked once, right? There was no multiplicity. Number 2, negative 4 works 3 times, and positive 1 works 2 times. Number 3, 0 works twice. Negative 5/3 works twice. Number 5, 2 works once. And negative 2 works once, so you don't really have to put any multiplicity there. And negative 3 works twice. That had x squared minus 4. It had this. So we had to break it down into x squared, or x plus 2 and x minus 2. And then for 6, we had to break down x squared minus 9 into x plus 3 and minus 3. But there was 2 x squared minus 9s. So that made negative 4 had a multiplicity of 3, positive 3 has a multiplicity of 2, and negative 3 has a multiplicity of 2. So 5 and 6, we had to finish factoring. The other ones we couldn't factor any further, 1, 2, or 3. Okay? Any of those you want to go over? That was pretty easy assignment, I thought. Maybe one of the easiest we've had. Okay? So tonight, like I said, you're going to have some that you do by factoring. This one, if you try to group it, it doesn't work out. Okay? That's what I would try first, is try to group these. And I can take out an x squared there and get x plus 6. And I can take a 4 out of there, and I get 3x plus 2. Are these the same? X plus 6 and 3x plus 2? So it doesn't work out nice as far as grouping. So, I would check quick. All right? But usually if it says identify the roots of each equation and state the multiplicity, it's probably one that doesn't factor. But I would check real quick. Again, once you get to here and see that, don't worry about it. Then just put in our calculator. All right? So here's what it looks like when you graph it. So what's happened? What's happening here when it crosses? What's it doing? It's bending, right? What did we say about that yesterday? If it bends as it crosses, what's that tell us about that 0? It works how many times? At least 3. Thanks, Neil. It works at least 3 times, an odd number of times. And if we look at our degree, we're supposed to find 3 zeros, right? So -2 has a multiplicity of 3. Now, here's what we do to make sure we're right on that. Okay? All right, we use synthetic division. All right, so -2 is one of the zeros according to our graph. Since it's bending, we're thinking it works 3 times. So I'm going to go 1, 6, 12, and 8. And see if it works 3 times. And how do I know if it works? What comes up here on the end? 0. You guys remember that? Okay, if I get a 0 there, that means -2 is a 0. Let's just see if it works all 3 times. So I drop my 1 down here. -2 times 1 is -2. When I add those, I get 4. -2 times 4 is -8. When I add those, I get 4. -2 times 4 is -8. When I add those, I get 0. So it worked the 1 time. And we know it should work, right? Because the calculator told us, right? Let's do it again, though. Let's see, because that's what we're thinking, because it bent, that it works a second time. -2 times 1 is -2. That's a 2. -2 times 2 is -4. It does work a second time. Again, we're thinking since it's bending, it's supposed to work at least 3 times. So we're checking that 3rd time too, just to make sure we're right. -2 times 1 is -2. And it does work 3 times. So we would say, since it bends, all right, this works 3 times, or has a multiplicity of 3. What do we think when it bounces off a 0? It works at least twice, right? An even number of times. Maybe 4 times. Maybe 6, depending on our degree. Okay, is that making sense? So synthetic division helps us make sure of what we're thinking. Okay? So why don't you guys do that quick? Use your calculator. All right? Figure out what they say roots, but that means the same as what? Roots mean the same as zeros. Okay? When it's an equation, they call them roots. When they write it in function form, f of x, g of x, they call them zeros. Same thing. So do that one on your calculator quick. And then let me know if there's any multiplicity. If something works 2 or 3 times, or maybe 4 times. Because we should be able to find 4 zeros. Yeah, let me give you, I'm supposed to give you a pass for that. Four. You guys get what I got? So what are we thinking? What's happening at -3? What do we say it's doing? Louder. What's it doing as it crosses? Bending. So what are we thinking about -3? Multiplicity of 3. What are we thinking at, what number is that? 1. It went straight through, didn't it? So how many times does it work? Once. So did we see all our zeros then? Yeah, we're thinking we saw them all, right? Because we're supposed to see how many? 4. See, our degree is 4, so we should be able to see 4 zeros. So when we see that bending at -3, it should work all 3 times. Okay? So multiplicity, or just put a little 3 times there, 3x. I mean, that tells me 3 times. Okay? Now, I want to check just real quick to make sure our thinking's right. So I want to put -3. And then we got 1, 8, 18. What is missing? An x, right? So I got to add a 0 to this one when I check. So 1, 8, 18, 0. And remember, that's -27. So -3, that's 5. -15, that's 3. -9. +27. Do it again, because we're thinking it works 3 times. That's a +2. That's a -6. So -3. That's a +9. So it did work. So we're thinking correctly. Let's just make sure. Yeah, it works. Okay, 3 times. So we were right. So the calculator found them for us. That one would have been hard to, well, maybe not. Might have been hard to factor. Could have pulled out a, yeah, it would have been hard to factor. All right. Making sense? Calculator helps us, synthetic division helps us make sure of multiplicity. Bending at least 3 times, straight through 1 time, bouncing off at least 2 times. Isn't that the same problem? Yeah, that's the same one, right? So, all right. So there we go. 5 problems again. Number 4 is like last night. And then 45, 48, 54, and 60 are like the examples we just did. Okay? Check for multiplicity. And, use your synthetic just to make sure, which doesn't take too long. Any questions? All right. Thanks for your attention.